Hello, geometry students. Welcome to the next edition of our notes titled 3-2 Inductive Reasoning. You should have already received this handout from your teacher, so we can fill in our notes as we go through this. All right, here we go. Inductive reasoning. Inductive reasoning simply means identifying a pattern using what we're given to find out what's going on. So the arrow stands for is. Inductive reasoning is using patterns to make a conjecture. And we've talked about conjecture before. Let me remind you, a conjecture it's a statement that you make, and you conclude this statement is true. So you use the patterns to make a conjecture. When you make that conjecture, you're believing that it's going to be true, and that's just a statement that you make. All right, something else we need to talk about with inductive reasoning is a counterexample. And we've talked about counterexamples in class. A counterexample is when we have an example that proves a conjecture is false. So it's actually giving an example. We're not rewriting a statement. We're not making a whole case for something. We can just simply give an example that shows something is false based on the statement that was made. All right? When we open up our foldable, it gives us our examples. So our first example, example 1, says find the missing terms in each sequence. There's 2 sequences there. And if you have not already, I want you to pause the video and identify, see if you can find the pattern, and then play the video and see what we come up with together. The first one gives us 1, 1, 2, 3, 5, 8. Okay, I can first look, am I adding the same number each time? Well, to go from 1 to 1, I add 0. From 1 to 2, I add 1. From 2 to 3, I add 1. From 3 to 5, I add 2. So I'm not adding the same thing. I'm also not subtracting the same thing. I can also look and see if I'm multiplying by the same thing. Well, I multiply by 1 to get to 1, but then I multiply by 2 to get to 2, and it's not the same thing each time there as well. I'm also not dividing. So we're going to have to take a look at this and say, what is actually happening? Well, sometimes we have to use each piece together, and I can see that if to get 1, I can add the 1 plus 1. To get this 3, I can add the 2 previous terms, 2 plus 1 to get 3. To get the 5, I add the 2 previous terms, 2 plus 3 to get 5. And again, to get the 8, I can add the 5 plus 3 to get that 8. So to get the next term in the sequence, I'll add the 8 and 5 together, and I get 13. If the next one is 21, and I want to get one more then, to get that final term, I can add the 2 previous terms, the 21 and the 13, and I get 34. Okay, my next example given to us, same thing, find the pattern. This one is a little more simple, I think. A1, BB2, CCC3. Well, it gives us one letter, gives us 2 letters, gives us 3 letters, so on and so forth. So the next one, I had 3 C's, so D, D, D. If I kept going, D, and that would be 4. All right? So patterns can be simply given to us like that. They can also show us patterns that they're drawn out. So I want to identify the next shape in each pattern here. Well, the first one it gives to me is a 1 by 1 square. The next one is a 2 by 2 square. And the next one is a 3 by 3 square. So I should know that my next shape will be a 4 by 4 square. All right, and then I can look at the shading. I've got 1 shaded, 2 shaded in a diagonal, 3 shaded in a diagonal. So the diagonal going up will be shaded for this 4 by 4 square. All right, the next one they give to me, I've got 1 point, and then 2 points, and then 3 points, and then 4 points. Again, I hope you guys have already looked at this a little bit and seen if you can identify by yourself. And so the next one, I'm going to have 5 points. And notice that they're all connected, and every dot is connected as well. So if I can connect this one dot to all the other dots, that's what the pattern is showing. Okay? My next one is a little more challenging. I've got a shield, looks like a shield at least, and it goes through. So my next one will be a shield as well. Same thing. There's 3 things going on here. First, I've got the numbers, 1, 3, 6, and 10. Well, what's going on each time? To go from 1 to 3, I add 2. To go from 3 to 6, I add 3. To go from 6 to 10, I add 4. So the next one, I guess I'm going to do this. Add 2, I add 3, I add 4. The next I'm going to add 5. So 10 plus 5 is 15. And then on the bottom, the shading is on the left hand, right hand, left hand, right hand. So the next one will be on the left hand. And the last piece is the circle. The circle is shaded, not shaded, shaded, not shaded. So this one will be shaded. All right. Example 3, this one gets a little more challenging. It's asking us to find the nth term in each sequence. So the term is 1, 2, 3, 4, 5, 6, 7, so on and so forth until we get to just n. And n represents any number in that term. The values, -2, -1, 0, 1, 2, 3, 4. All right, here's how we can always solve this. So they give us this table. I can first identify what's the difference between all the values. Well, to go from -2 to -1, I go up 1. To go from -1 to 0, I also go up 1. And it looks like I'm going up 1 each time. Check them all. Make sure every time you're identifying the pattern, you're going to look at every single term. Don't just do the first couple. All right, every single time I go up 1. So that gives my coefficient in front of n. So my coefficient is 1, and it's n. Then go back and identify what else are we doing with that to get our actual value in the term. So with the first term, I'm multiplying it by 1. So 1 times 1 is 1. And then how do you go from 1 to -2? Well, you can subtract 3. Try it again. If you've got 1 times the number, so 1 times 2 is 2. To go from 2 to -1, I also subtract 3. Check it again. 1 times 3 is 3. To go from 3 to 0, you subtract 3. And I check all of these to make sure I'm doing the exact same thing. I'm subtracting 3 each time. So also with the 1 in, I subtract 3. I'm going to do something here. I'm going to draw in one more example for us to do because I feel like this one needs another example. So if we gave another value, draw this with me, 5, 8, 11, 14, 17, 20, and 23. Okay? And we're going to identify what is the pattern based on that nth term. Okay, so this is my first term, second term, third term, fourth term, fifth, sixth, and seventh, and so on. Okay, do the same thing. Identify what's the change in values each time. To go from 5 to 8, I go up by 3. Am I going up by 3 each one? Check it. From 8 to 11, up by 3. Yes, up by 3 each time. So that, again, is my coefficient. So my coefficient in front of the n is 3. Multiply the term by 3 first. Then go check, okay, if I multiply this term by 3, what else? Well, 1 times 3 is 3. How do you go from 3 to 5? You add 2. Check it again. If I have 3 times n, 3 times 2 is 6. To go from 6 to 8, I also add 2. 3 times 3 is 9. Add 2 to get to 11. So again, 3 times 4 is 12. Plus 2 is 14. So I'm adding 2 each time after I multiply by 3. So this is 3n plus 2. All right? Rewatch that if you need to. That one's a little more challenging to identify the pattern of the value of the nth term. Last example here. We're also going to still find the value of the nth term. We have polygons, and the measure of the exterior angles are shown. Write a rule for finding the measure of the exterior angle. Okay, we want to find just one exterior angle here. So I've got a triangle here that has 3 sides. Quadrilateral has 4 sides, and a hexagon has 6 sides. So over here I'm going to make a table. Help us out here. If I have the nth term, and it gives me one exterior angle, with 3, one exterior angle is 120. With 4, it was 90. And with 6, it was 60. If we also look at the total, it might help us identify how we can summarize this. Well, if the exterior angle is always 120 for a triangle, and always 90 for a regular quadrilateral, this one's a square, and for a regular hexagon, it's 60. Again, this has to be a regular figure, which means all the sides are the same. Okay? So I noticed that adding them all up, 120, 120, 120, 90, 90, 90, and 60 6 times always gets me a total of 360. This is a pattern that we should have already seen. But how do I take this and find the measure of just the exterior angle, one exterior angle? Well, if they're all up to 360, I could divide by 3 to get that 120. If they're all 360, divide by 4 to get 90. Take the 360, divide by 6, and I get 60 there. So my pattern is, if I have 360, I divide by n to get the value of just one exterior angle of a regular polygon. It shows a regular polygon. Okay, we will practice this more in class. Again, this is based on patterns, and we can use those patterns to make statements, which would be called a conjecture. And anytime they want to disprove the conjecture, we can give a counterexample, which would prove it false. All right, guys, have a great day.